Then it is relatively cumbersome. Then the corresponding dynamic routing. It can solve this problem. If a network segment already exists in the overall network topology, in the future, this network segment will disappear. It can automatically tell other devices. This is the difference between them. That is, only preconfiguration is required. In the later stage, all their information can complete automatic interaction. This is the biggest difference between static routing and dynamic routing. The difference at the configuration level. In fact, it's better to solve. Because now for the project. Actually, the configuration of many projects at the beginning. It's all configured automatically. Our templates. And change it inside. Including what we'll talk about shortly. We will have corresponding SDN controllers like this. We can send configuration to downstream devices. Even post the phenomenon. All okay. So although the configuration is cumbersome, but actually, the biggest difference between them is not in the configuration, but in the perception of changes in the network. That is, in the future, when our network changes other than, whether it can be updated and maintained automatically is the most important thing. Because we don't want, after a network is established successfully, have to stare at it every day. Adding or deleting a network segment requires manual configuration of dozens or even hundreds of devices. This is too exaggerated. So that's one of its downsides. We're going to learn another form of routing next. Dynamic routing. Both static routing and dynamic routing are a method of adding routing table. They are used to calculate the routing table. There are direct and static routing tables. There is also a dynamic. In a larger network, we can use dynamic routing. Automatically sense network status changes and network topology changes. This is another form of routing table construction. Let me tell you about the concept of dynamic routing. By running some corresponding protocols on the device. These protocols are some dynamic routing protocols. The process of automatically exchanging routing information through this protocol. Dynamic routing. That is, just need to run some kind of protocol on the device. Automatically exchange routing information through this protocol. This is called dynamic routing. There is no algorithm for static routing. It only relies on human configuration. And dynamic routing has an algorithm. This is a difference between them. The concept statement mentioned on the PPT is more official. Generated by interactive routing information. And maintain the routing table required by the forwarding engine. It is the routing table when data is forwarded. Admins don't need to be like static routes. Manual maintenance. Run a routing protocol on each router. It means at least 2 routing protocols. It is called each. If there is one, it will not be able to run the routing protocol. Because a routing protocol is not a router. A routing protocol requires at least 2 routers. It doesn't make any sense to turn on a router. It has no way to exchange messages with other devices. If a company only has 2 devices, usually go static. So actually, dynamic routing protocols are considered for medium and large enterprises. If it is a small business, just a router, there is no use for this thing at all. We need on both routers. Run the same dynamic routing protocol. For example, run a RIP protocol on the left. Right running an OSPF protocol. There is no way to establish a relationship between them. There is no way to learn routing from each other. Both of them must be the same dynamic routing protocol. So at least 2 devices. The protocol running between the devices must be the same. Otherwise, there is no way to learn through a certain agreement. You will learn later. For some medium and large networks, multiple routing protocols may be running at the same time. It's also possible. It is possible to run both. For example, EIGRP and OSPF are used together. It's all possible. But we don't need to think about those now, because those are related to network architecture issues. Just run the same routing protocol at this stage. Let's go on. Routing protocols have some corresponding features. Maintain routing information. It's just some updates and maintenance in the later period. There is another one called determine the best route. Let me tell you about this. There are now two devices. An OSPF is running between the two devices. So now suppose there are two paths to go. We run an OSPF. OSPF has an option value. What exactly is the best route? Which route is better? Now that the routing protocol is consistent, management distance is definitely the same. If we compare, we'll only compare routing metrics. Then, for such a value, it is calculated differently. OSPF selects the best route based on bandwidth. Suppose the line above is 10 G. The following line is 10 M. Then it will choose to take the above route, because the upper band is large. This is called determining the best route. After determining the optimal path to any destination. Actually, the best route is calculated. Then next, the routing table will be built based on this information. Same destination network. For example, I learned a 1.1.1.0 network segment here. An OSPF is running between the two devices. Learned one thing from OSPF. Run another RIP. I learned a lesson from RIP. Also running an EIGRP. Another lesson learned through EIGRP. Then finally compare the administrative distance of the three routing protocols. You can also choose an optimal addition table. Is to create a routing table. So it's all a process of comparison. In the end, a static route kills all dynamic routes, because the static administrative distance is 1. Lower than all dynamic routing protocols. Static routing is not only used by small businesses, medium enterprise, large enterprise, including current operators are using, because the dynamic routing protocol has a fixed principle of routing. Just like the OSPF I told you. It's based on bandwidth. Suppose the above line is 10 G. 1 G for the following line. Always go above. Never go below. For example, future data will go to the destination network. Very much traffic. Traffic will be congested, because now there are two lines. The following 1G line will never go. That is, if the network does not fail, never go the line below. Will cause all traffic to go only above. At some point you'll find out. If the concurrent network traffic is too large, it will cause the above overall link bandwidth resources to be full. But the following link is idle. This is often. At that time, we can enter static routes in a targeted manner. For example, which destination network segment will the future data go to? Let this part of the traffic flow downward for traction. That is, the combination of dynamic routing and static routing is also very common. Don't understand that static routing is no longer needed. Not only small businesses use static routing. It is a controllable mode of operation.